Hello everyone, my name is Hanqiu, and today I'm going to give a speech about my honors presentation, which is measuring color vision deficiency. First of all, let me introduce my advisor, Professor Andrew Elliott, who is an expert in the field of social motivation and color. And thanks to his advice and help, we can finally get this project done and analysis. Thank you, Andy. So before I dig into our presentation, I want to ask everyone a question. Do you know if you're color deficient? So let's imagine a scenario where you were in a kindergarten and your kindergarten teacher was teaching you about discriminating between a red and green traffic light. Your teacher might say that the red-green color are pretty different from each other. So it's easy for you to distinguish and that's how you cross the street. But for some of you, you might notice that well, I don't see that kind of difference. The red-green traffic light look pretty similar to me. So starting from that point, you might ask yourself a question, am I colorblind? So this kind of personal experience is what we're interested in for our study. So we want to know if people understand about their own condition of color vision deficiency based on previous experience. So the previous experience not only include the stories that I just told you, like the personal stories, but also can include like the officially diagnosis by a doctor during a health test, for example, in primary school. So this is also included in the personal experience that we're interested in. So if people do understand about their own conditions about the CVD, is self-report a reliable way to detect color vision deficiency? So let's just introduce the CVD first. So overall, CVD is divided into congenital CVD and acquired CVD. And congenital CVD basically means it is present from birth, and acquired CVD happens sometimes after a disease or injury. So for congenital CVD, it has three different subcategories: anomalous trichromacy, dichromacy, and monochromacy. So anomalous trichromacy just basically means reduced sensitivity to different kind of lights. And dichromacy is the inability to see different kinds of lights, which is a little bit severe than the previous one. And monochromacy is just the inability to distinguish any color. So your world is totally like a black, gray, and white thing. All right, so for our study, we mainly focus on protein, deuterium, tritium, but not on monochromacy, basically because the population of monochromacy is pretty low, that it's hard for us to find enough data and to do the analysis in a limited time. So people have done a lot of like scientific research about measuring out the CVD, and some typical measures are including test of discrimination, test of matching, and computer control color test. So for our study, we're using the two plate tests. The first one is the widely used Ishihara plate, which is the circle look like this. It has a different kind of numbers in it, and I bet all of you have used it before. But the concept of it is that can only detect the red-green color deficiency. So that's the reason why we're also using the next test, which is the HRR test. So this one looked pretty similar as the Ishihara plate test, but it has 4 different corners, and a figure can occur in either of the 4, and participants are asked to trace the figure. And this one is pretty good, is because not only detect the red-green, but it also detect the blue and yellow color vision deficiency. And also it detects the severity of different kind of deficiencies. For example, the trichromacy, the dichromacy can also detect that. So which is pretty ideal for our study. All right, and also scientists have developed some self-report questionnaires about the CVD. For example, in 1987, Karen has developed some self-report questionnaires about the overall vision. So he includes different kind of aspects of vision, and the color-related items are included. For example, do you have difficulty discriminating between red and blue? And do the color names that you see, that you use disagree with those that other people use? And after a year, Karen developed a new screen. It's not a new one, but it's an updated one, only specific to color. It's called the Color Vision Screening Inventory. And after 4 years, Lowen write an article telling the pros and cons of the CVS that Karen developed. And he kind of developed a new one called the Visual Activities Questionnaire, also including some color-related items. For example, do you have difficulty matching clothes? So for our study, we are using Sona to collect data, and we have been collecting data for about 2 years, and we're still going to collect more data in the future. I'm not sure when it's the end, but it just depends on how many color deficient participants we've got. So although we've got about 700 participants, only about 20 of them were color deficient, so which is not ideal because many more data is needed to help us analyze the data. And since we're also interested in different kind of categories of CVD, we just need more and more data. And you might ask me a question like, why don't I just go to a hospital and try to find the archive data, right? Like hospitals have some data about who has the color vision deficiency and who has not. And why don't we just try to contact those people and try to see if they're interested in doing our research? The reason is that we don't want to try to, okay, somebody's joining. We don't want to try to search for a specific population because what we're interested in is to figure out the overall distribution of the population who understand about their own conditions of CVD. So that's the reason why we're just using the Sona to collect participants, and we want the sample to be totally random. All right, and here's our descriptive statistics. About 73 participants are female, and most of the participants are white and Asian. And we also asked a question about which is true about their vision, and most of them is corrected with glasses, and also many of them is fine without any correction in their vision. And here's our procedure of doing the research. So we first asked participants to do a self-report questionnaire on a computer in our lab, and then we're asking them to do 2 Ishihara plate test and HR plate test. So those are the objective measures that we did. So the reason that we were doing the self-report questionnaires before doing the objective measures is because we don't want the results of the objective measures affect the participants' original responsive to the self-report questionnaires. So for example, like maybe I did the HR test and figured out that hey, I might have some weird thing going on with my vision, with my color vision. So that may change my original response of the self-report questionnaire, right? So yeah, and that's part of the personal experience that we're interested in. Yeah, so that's the reason we're doing the self-report questionnaires first. All right, and here's the self-report items that we're using. So we're using 3 items from the CVS, 1 item from the VFQ, 3 items from the VAQ, and also just a general question, are you colorblind, which is widely used in the previous literatures. So we're using part of the previous inventories. Like you might notice that we're only using like 1 or 3 of the previous inventories. Like it is because our mainly focus is not just to replicate the previous studies. Like we are not interested in to see the reliability of the previous inventories. We just want to know like if people understand about their own conditions of color vision deficiency. So that's why we're creating our own inventory by combining the previous inventories and creating some items by our own. And the items created by our own is listed below. For red-green color vision deficiency, we have items like, do you have difficulty seeing red and green? Do you have difficulty distinguishing red and green from other colors? And are you red-green colorblind? And similarly for the blue-yellow colorblind. All right, and here's our result. So first of all, we want to test the correlation between the 2 objective measures. So our hypothesis is that the 2 objective measures are, the correlation of these 2 could be really high. Because they're just basically testing the same thing, the red-green color blindness. And the p-value is pretty small, which is really ideal. And we're using the chi-square test to test that because those data are just categorical, a yes or no. A yes means you are color deficient and no means you're not. And here's our results for the subjective and subjective measures. So the table here is a little bit big, so I'm going to explain it a little bit. So for the first three items over here, are you colorblind, are you red-green colorblind, and are you blue-yellow colorblind? These three are the categorical items. Like the answer of this are just yes or no. And the four items, the CVS red-green, the VFQ, VAQ, and red-green items developed by Andrew Elliott. So those four items are continuous variables. So that's the reason why we're using three different kind of analysis over here. For chi-square test, we're just basically testing out the correlation between the two categorical variables, like over here. For this part, we're using the chi-square. And for this part, since we have one categorical and one continuous variable, we're using the Point-Becerril correlation. And also for this part, those are just the same thing. And for this part, we're just using the typical Pearson-R correlation for two continuous variables. And as you may notice that there are some NAs in there, it's just because we cannot just correlate the BY item. BY stands for the blue and yellow. We cannot just correlate the BY items with the red-green items together. And the correlations are pretty high, and all of them are significant, which is perfect. And we also noticed that there are some really highly correlated items. Like here we have a 0.79 and a 0.77, so which is perfect for our study. So we also have the results for the relationship between the objective measures and the subjective measures, which is exactly what we were looking for. So if the correlations are pretty high and are significant for this section, it just basically means the results of the objective measures matches perfectly with the subjective measure that we created. And the results are pretty ideal. Like the significance, they're all significant, and some correlations are pretty high. Also, you may notice that there are some NAs in here. It is because, as I mentioned before, we only have 20%, like 20 participants who are color deficient, and of the 20 participants, 0 of them are blue-yellow color deficient. And in other words, the 20 participants are all red-green color deficiency. So in that case, we cannot just use the objective measures to correlate it with the BY items, because the BY items for the HRR is just a 0. Okay. All right, so here's our conclusion. The objective measures are correlated, the subjective measures are all correlated, and objective and subjective measures are also correlated. So highly correlated items are you colorblind? Are you red-green colorblind? And we also have highly correlated items like, do you have difficulty discriminating between red and brown? Do you have difficulty seeing red? So in other words, when we ask people like this kind of questions, people answer really accurately. Like their answer are pretty accurate based on their own objective measures of CBD. So they quite understand about their own condition of color vision deficiency based on these questions. So again, we can't do blue-yellow subjective items and objective measures correlation because our sample of the blue-yellow color deficiency is a 0. So that's why we're trying to continue doing our research and try to collect more and more data. So we decided this is a priority. I'm just analyzing the partial data set for now for my project. And also the reason that we're continuing doing our research is because we're also interested in the severity of the CVD. This can be measured by the HRR, as I mentioned before, but it's just because we don't have enough data for analyzing it. We are also interested to see the difference between the congenital and acquired CVD. And we are also interested to have a more wider range of the age, which means that we want to know, like, from what age can the people understand about their own condition of the CVD, which stands for the color vision deficiency, and what is the accuracy of different ages. And finally, we aim to build a reliable subjective measure to detect CVD, which could be used in the future, like in the clinical area, or it's just a pretty efficient inventory for people to use. Like, they don't need to buy stuff like objective measures. They don't need to buy some plates. Just spend like 2 minutes to do the self-report questionnaire, and then they understand about their own condition about a CVD. And that's it. Thank you so much for coming to my presentation today.